Good morning, good afternoon, good evening, everyone. Welcome to our technical webinar today, which is on rain and cyclone forecasting. My name is Pearl Winchester. I'm from New Caledonia, and I am co-animating the community of Oceania Geospatial Water Resource Workgroup with Nicolas from Fiji. I'm going to share my screen straight away. Up and then we. So yeah, we are the animator. So just so for people that don't know us yet, I'm from New Caledonia. I'm now working for Insight, which is a. Oh, am I sharing my screen? I'm not. I forgot to do this. Share my screen. There we are. Sorry about that. All right. So yes, I'm Pearl Winchester. I have been working 14 years in the water department of the government of New Caledonia, and now I'm working for Insight, which is a private company, member of the network ART Geo Development in New Caledonia. I'm also a student in Paris at the moment since last year. If you want to know more, you can check out my profile on LinkedIn. I'm going to let Nicolas introduce himself. Please, Nicolas.
Thank you, Pearl. Good morning, and good morning, everyone. My name's Nick, and I'm working with SPC. My background is also in hydrology, but I'm working currently in more of this Earth observations and GIS space, and supporting the Water Resources Working Group for the Oceania Geospatial Symposium. Thank you.
And if you could introduce yourself in the chat with your name, role, and country, so we know who is with us today. With us today, we also have, I wanted to talk about this before, just a reminder of our community of Oceania Geospatial Workgroup. It's a workgroup that wants to share information and knowledge for the benefit of the Pacific Islands and countries and territories in the geospatial field. So geospatial is really wide, from GIS, satellite, UAV, survey, GPS, for water resource and for Oceania. And you can join us on LinkedIn. Here on the right, you have a few topics that we would like to address in the coming year. But as you can see, we have the small dots. It's completely open to whatever you would like to be talking about. And today with us, today with us, we have our speakers, which are Moirah Matou from Vanuatu. Moirah, if you can introduce yourself, please.
Hi, good morning. Well, good morning from Vanuatu, everyone. I'm very happy to be part of this webinar today. I will be giving a presentation on climatology, maps, and information that the Met Department, gives out to the public. My name is Moirah Matou. I'm project manager of VanKIRAP, which is a climate information services for resilient development in Vanuatu. Thank you, Thomas.
Thank you, Thomas, Moirah. We also have with us Rua. So I'm just going to share my screen again just so people can read. And then Rua, you're going to introduce yourself also. So up, yes. So
hello, good morning, everyone.
Yeah, go ahead.
Good morning, everyone from Papua New Guinea. My name is Rua Puka. I work as a GIS specialist with the UN International Labour Organization, to be specific.
Thank you. Perfect. Before we start, I wanted to have a short poll. It's going to be really quick for everybody to give us their opinion. And the short poll, it's going to be like super easy, as you can see. And here, It's a very easy question. See, it's how often do you look for rain forecast or weather information? And you will have this answer. All right, so I'm just going to launch the poll inside the webinar. It's right here. Give me a minute, it's charging, and there we are. You're gonna have the poll online on your screen right now. So if you can just please answer the answer that fits the most for you. Like for me, it's gonna be this. And so the questions are coming up. We have once a week, once a month, daily. Someone is watching looking at rain forecast pretty much daily. Every 2 or 3 days, okay. More answers coming up. We have 6 answers. We should have 10. So some people didn't answer. It's coming, it's coming. Other answers. Just another few seconds to answer. Ding, ding, ding. Anybody else? Is it working for everybody? I hope. All right. Okay, I guess that's going to be your last answers. So most of everybody, I don't know if you can see the results or if it's only me, I can see the results. But most of you are looking at the rain forecast every 2 or 3 days. Some are looking once a week or once a month, and 1% is actually looking at it daily. So that's pretty good. Thank you for this. And I'm just going to give the floor to Moirah now to talk about the VanKIRAP project. And I'm going to share my screen up for the slides. It's good for everybody. Everybody's seeing my screen with the speakers today. I hope so.
Yes, we do.
Perfect. Merci. Moirah, the floor is yours. And we've lost Moirah from Vanuatu. Oh yeah, it seems like we've lost Vanuatu. The connection of Vanuatu is not working anymore. Is that what's going on? I guess it is. I'm gonna try to reach her on WhatsApp. Maybe Nicolas, we're gonna do your presentation, and I'll try to see what's going on with Moirah on the side. Is it okay with you, Nicolas?
That's fine, Pearl. I just want to check, do you want me to share my screen or will you still be sharing the screen?
I can share. I can share my
Okay.
screen.
No problem.
I'll do it. And you are here. There you are. Go for it, Nicolas.
Sure, yes. Thank you, Pearl. So as we've covered in the introductions, my background is more in hydrology, so I'm not a meteorologist. My presentation here today is more to share about some of the background of this topic based on some of the research that I've been doing for my thesis that does cover tropical cyclones. And so I'll be covering the trends, some of the models, and some of the different data sets that are useful, particularly for GIS and remote sensing users and practitioners. So, yeah, thank you. Plus, So yeah, the overview of this presentation will be mainly a scientific literature review. So I'll be covering a range of different papers about the key trends with about the tropical cyclone models. And then I'll be sharing some information about some of the key data sets, as well as some tips for plotting and visualizations. So this is just the kind of anatomy of a tropical cyclone. You have the eye and the outflow cloud shield, as well as these spiral rain bands. That is what you usually see from a bird's eye view. We don't usually see this kind of cross section view, but that's the overview of the anatomy. It's a bit exaggerated horizontally, but that just shows you what's going on underneath all of the clouds and rain. Plus. So in terms of the scientific literature review, I'll be talking about a few of these papers. I won't go through all of them, but in essence, you can see here through the highlighted titles that the key points of each of these about the recent research on tropical cyclone trends, particularly in the Pacific, where there are the global models show us that there will be a decline in the frequency of tropical cyclones under climate change. However, some of the tipping points that we're seeing in the climate systems are pushing us towards more intense tropical cyclones due to El Nino climatological phenomena. And also we're seeing that this is leading to increased risk of tropical cyclone damage. And the risk and the damage is not just clearly linked to the intensity of the tropical cyclone hazards. It's also linked to the growing exposure of assets and the vulnerability that these assets are facing from these hazards. So it's more complex than just saying because cyclones are becoming more intense that we're going to see much greater impacts on economies throughout the Pacific and throughout the world. Next, please. So one of the first papers I wanted to share was this paper by Peduzzi et al., which talks about the global trends in tropical cyclone risk. Basically, what the group found was that based on observations from satellite imagery and GIS data over the last 40 years, that there have been relatively similar numbers of observations over the past 40 years and the current trajectory. However, yeah, so what the studies are showing as well under some of the models is that we're likely to see that the frequency or the number of tropical cyclones in 1 year is likely to decrease or remain roughly constant. So it's going to kind of plateau and level out. However, even though the total number of tropical cyclones will decrease, the total intensity of the cyclones is likely to increase, with the frequency of the strongest storms also increasing. I spoke a little bit earlier about exposure to these hazards, and this increasing exposure is largely because of socioeconomic dynamics such as population growth. Plus, these are some of the figures from that study that shows the distribution of tropical cyclone hazard frequency and mortality risk, where you have lower risk in blue in the ocean and higher risk in red. And then on land, the lower risk is in green and the higher risk is in red again. So we're seeing probably most of the risk in occurring throughout Asia and America. However, this is just the absolute numbers. Can we go to the next plus? In terms of the relative numbers, and I think this is also really important for the Pacific and Oceania, the key point here is that even though we're seeing this kind of, there has been a change in the number of tropical cyclones over time that will eventually kind of level out or decline, that countries that are most at risk in terms of the total mortality risk divided by the total population in millions are often the countries in the Pacific because of a high kind of exposure and compared to the total population, which is relatively small. So here we have Vanuatu and Fiji in that top kind of area of that plot, which shows the modeled fatalities per million per year relative to total population. Plus, yeah, and this table just summarizes some of the key trends over the past decades, where we've seen that the number of times, number of physical events recorded, and the number of cyclones making rainfall being approximately half of the total, or a bit less than half, and then the number of times that TCs have hit countries as well being recorded there. So this just gives a bit of a summary from that study. Plus, the next study linked directly to this was the socioeconomics of cyclones by Noy. And this really relates the hazard characteristics of cyclones to, you have a hazard. So from a geospatial perspective, if you're trying to model or measure this risk, you would have a hazard layer. You would have an, which could be your tropical cyclone path or the wind swath as a raster. You would have your exposure or your assets, which would be, for example, infrastructure or areas of high population density. And then you might have other layers that might relate to vulnerability, such as natural shielding from vegetation. Plus, so in essence, what these studies are basically talking about are how, because of the increases in global population and the increased coastal development, we will see increased exposure of assets and populations to tropical cyclones, even if the number of tropical cyclones is stable or declining. So that's something that came out of this study. The study also talked about both indirect losses as well as long-term losses to well-being from these hazards. Plus, Mendelssohn, another study, looked at the impacts of climate change on global tropical cyclone damage, and the models basically highlighted that this increasing intensity, including the rainfall intensity from tropical cyclones, and that there could be an approximate doubling of the economic damage due to cyclones from approximately 26 US billion to approximately 56 billion to the gross world product, or every country's GDP overall, cumulatively. Plus, so these are some of the figures from that diagram showing the distribution based on the distribution of tropical cyclones. Plus, and this was the kind of linking back to the figure that we talked about before. Even though most of the actual population and economic damage is projected to be seen in East Asia, North America, Central America. However, when we look more at that's on the left, but on the right figure, if we look more at the ratio of GDP divided by the total GDP, so like the amount of impact to each country's total relative to the total GDP of each country, Oceania is much more impacted because of their relative GDP. Plus, yeah, so this study talked about the declining number of tropical cyclones into the future under global warming, and basically showed that there would be a declining trend. That might be that a stabilization, so the rate of increase is declining, or it might be a decline overall in total number. Plus, so even though there was a projected decline in globally, within the Pacific, where the El Nino climate phenomena is more apparent, studies also showed that TCs could become more frequent in smaller subregions, or that higher higher intensity cyclones will become more frequent. So that's particularly based on the examples of Fiji, Vanuatu, Marshall Islands, and Hawaii. Plus, now this is some examples of basic plotting that I've done of tropical cyclone paths, and the point here is that this is quite messy if you just try to take data, geospatial data, and just plot all these cyclone tracks. It can become quite messy because there's so many of them, and this is only from the past 20 years, the more high intensity ones. Plus, and you can see a large kind of concentration of these over Vanuatu and Fiji in this particular panel. Plus, and yeah, and even more widely, globally, it gets very messy if you just try to take all the tropical cyclone data and just plot it. Plus, so if you are trying to work with the geospatial data sets to plot out tropical cyclone hazards, one data set that we can recommend is the IBTRACS, which is the International Best Track Archive for Climate Stewardship, which is developed collaboratively with the World Meteorological Organization, as well as regional specialized meteorological centers. Plus, so some better practices for plotting could include models of wind speed or wind pressure in this kind of raster format, plus, or plotting tracks of potential tracks or past tracks of cyclones based on based on the data and observations. Plus, one last point I want to make is just that in the southern hemisphere, so I think PNG, the New Guinea island, it's kind of touching it's like at the very top of the southern hemisphere, and then everything else, all the other the countries we've been talking about fit within that southern hemisphere. In this region, tropical cyclones rotate clockwise, whereas in the northern hemisphere, the tropical cyclones rotate counterclockwise. And so we need to symbolize this as well in GIS. Plus, again, plus. So yeah, so there are different symbols to show this. So you can see here the southern hemisphere examples and the northern hemisphere examples. And you can also see that different categories from tropical depression all the way up to full-on Category 5 tropical cyclone. Plus. So that covers the kind of background to introduce this topic, particularly the scientific literature and past studies. And from here, we will have our other speakers who will be sharing about rainfall, for example, and hopefully, as well as our colleague from Vanuatu, Moirah, to speak about her area as well. Thank you.
Thank you very much, Nicolas, for this presentation. I don't know if Moirah, you are back with us or not.
Yes, I'm here. Hope you can still hear me.
Yeah, we can hear you. That's perfect. So I'm going to share the slides and the floor is yours. Share, I said share
Thank you.
first. Right. All right. All good.
Okay. Thank you very much, Pearl. So I will be presenting. I will be presenting on the VanKIRAP project and Vanuatu Meteorology and Geo-Hazards department. I will give you a little bit of background on what the services that we provide and how VanKIRAP project has come up to help to enhance the services that VMG, yes, the Vanuatu Meteorology and Geo-Hazards Department, or VMGD, provides. I apologize, I will not turn on my camera because of the low bandwidth that I'm getting this morning. So the outline of my presentation, I'll give you an overview of the work that VMGD and VanKIRAP project does. And then I'll talk about, as I have outlined here, firstly, the weather forecast services, climate services, the climate data, climatology maps, and a few of the best practices that we have come to learn during this implementation of the project. So VMGD is a government department which provides services by giving out weather forecast, climate prediction or seasonal forecast, tropical cyclone forecast, including partly hydrology. It's not fully established yet, but we also have earthquake information and volcano information that alerts that go out as well. So that's VMGD. VanKIRAP, as the name says, Climate Information Service for Resilient Development, is a pilot project funded by Green Climate Fund, GCF. It's especially come in to enhance the current services that VMGD is already giving out, improve it, but also help to start off new products and services that can drill or be spread or shared right down. Sorry, relevant is the word, right down to the community level. Being funded by GCF, I also want to acknowledge SPREP, who is the accredited entity. In the project VanKIRAP, we tailor climate information to suit sector needs. So as I've listed here, agriculture, fisheries, tourism, and infrastructure. So we've tried to develop products that suits are suitable and specific for these 5 sectors. Also with VMGD, because it's a very big need to increase spatial coverage of monitoring devices. So we increase the land monitoring devices, automatic weather systems. We've installed 16 of them. That adds on to about 8 already on the ground. And then we installed an automatic river gauge. There's only one in the whole of Vanuatu, but it's a start. There are other projects coming in to take that on because rivers are also giving hazard to the communities when there's flooding. Then we have buoys, ocean buoy that has sensors as well to monitor waves and temperature of the ocean. We have about 7 or 8 on the ocean that are giving live monitoring. And then we have a whole storage of climate data, digitalized as well in the archive of VMGD. And this is a big asset for VMGD as it continues to use this data to continue to develop more informative products or services for VMGD. Next. So for an example, what weather forecast services use is this kind of models. This is an web-based model that is accessed by our weather forecasters to see the global systems that come out, the weather systems that move into the region by the contours of pressure. We see the contour lines that are in the map, and also you can see the green shades. Sorry, Pearl?
Yeah, go ahead. It's all good.
Okay.
Yeah.
The green shades are the rainfall forecast. And you can see the islands of Vanuatu are very tiny in there, but that's about all we get. So if our biggest island, you can see the largest island of Vanuatu, if it says, if it shades all green, that means all of our big island, Santo, will have showers. That's about all. But in actual fact, in reality, you will find that not all of the island are going to expect showers. It may turn out patchy, but those are the models that we use. So that's an example of where the information comes to for us to do weather forecast. Here's another example. We use the model from Australia, and similarly, you can see pressure lines that shows weather systems that move across Vanuatu, high pressures and low pressures, and these are what builds up rainfall over the country. And again, you see our islands are quite small, and the whole of one small island is shown to be expecting rainfall, whereas in reality it might not be. It needs to be more. Yes, it needs to have a higher resolution, and this is why in my previous slide, I think it was the third slide, that we need to increase the number of automatic weather stations. The more we have, the more information fits into our global models, and then we can have a higher resolution, precise weather forecast. Okay, this is an example of tropical cyclone. Sorry, next. Tropical cyclone forecast. So we give out the weather forecast, gives out a 5-day outlook, a tropical cyclone. Yes, this is all on tropical cyclone. It gives a 5-day outlook, and then if there's a cyclone within the area of responsibility, then we give information. And if it's going to hit Vanuatu within 48 hours or so, we give out advisory. And then if it's within 24 to 12 hours, it is a warning. And we put the information in a tropical forecast track map like this. Maps are very powerful because people can see where they are at and where the cyclone is coming from, which area should be prepared, which area or island should be staying indoors, and which area of islands should just keep watch and prepare. So this is very, very important. We also supply just a map like this on the top left, right. We give the location by letters and numbers, and people can mark on the map where the cyclone center is. That way it also helps them to prepare. We also have on the side left panel each category of the cyclone and one sort of the picture of the damage that it can cause. Because a lot of people in the islands cannot read, but they can read a picture. So this is how slowly VMGT is using maps to give out information to the public. I'm hoping my next, yes, sorry, Pearl, next slide. So now coming to the project, we installed, I mentioned we installed a river level monitor. This is to help us see how the river is behaving, and we give out severe weather information to the public, especially within the catchment area. If the flood, there's potential flood, we can forewarn people in the community. You can click on the link, yes, yes, okay. And then just scroll up, please, Pearl. So this is the information we get, right at the bottom. Pearl, keep going. Yes. So this is the, you can stop there. So this is the information we now have possible on desk or on the bench, as they say, for the weather forecasters to be able to see the level of the river, how much rain is falling along the catchment. Another project called Vanuatu Coastal Adaptation has also taken this and as an example, and is going to install another 3 automatic river gauges. This is only the beginning of monitoring. First, we have the data, and then eventually we can map these river catchments in the future, and be able to understand more how the river will behave, and also this can help our disaster office to better prepare the community. Yes, thank you, Pearl. Next. Okay, for the climate services, this is an example that we start off with, working with NIWA from New Zealand. They converted the information, the data that we get from from the automatic weather stations, is converted into this sort of like what do you call it? Information or info byte. I forgot what's the word. Infograph.
Infograph, yes.
Yes, infograph. So that our sector, so you can see these are specified for each of the stations that our monitoring devices are based. So we have one at in Ambai, that's one of our islands, and then another in Anaitshom, our southernmost island, down south. And these are the infographics that are available on website for people in these islands, especially like for this one, they are both for agriculture, but they are specific products for water as well, and tourism, all the sectors that we are partners with, so that it's more specific. It provides information how many days in a month there's no rain, how many days, like consecutive days, there's been no rain, or there's been rain, the total. It makes a summary and just, highlights information that is useful for the farmer. So soil moisture, you can see it's there. Growing conditions, it comes as dials at the bottom, maximum temperature and minimum temperature. And that way, the farmer slowly understands the weather or the climate for the area, particular area or community where they are based. So that's, yes, that's the infograph that it's live on website, and it's updated. It's updated daily. Okay, then when VanKIRAP came along, we've developed, put these climate data from automatic weather stations, converted them into maps. So we'll have a look at some of these maps. Pearl, you can click on the first link. Yes. So you can see this is not into the future. This is based on past climate data. We cannot develop our own models yet. That's our dream in the future, to be able to do that and localize yes, the more localized modeled weather forecast. So here, this is the last 30 days rainfall accumulation. This is useful for especially infrastructure and also health, because you are able to see in the past month or in the last year, if you have cases of malaria, for example, you can see that you can see how much rain we have been getting. And then you can make an analysis to see the impact of rainfall on diseases that spread. You can also make an analysis for islands or coastal areas if infrastructure or public works is deciding to build roads, doing some big, large construction. They can understand when is the best time to build to avoid a lot of continuous rainfall. So that's the usefulness of this particular map. So you can have daily maps. If you click on the select data, Pearl, you can go to mean temperature or mean temperature anomaly. Yep. Yes, last 30 days. Okay.
Yeah, it's going to update. It's going to take a bit of time to update, but it's going to get there. There we are.
Yes, yes. So, okay, I think that's not working.
Oh.
Maybe mean temperature. Yes, it says data gaps there. So
Let's see. I can take many more days if you want.
yes, looks like that one is not working. So we can yeah, let's try another tab. Not another tab. Sorry. Let's try. Can you go to select map set and go
Yes.
to historic maps?
Okay.
And then, yes, you can just select one of the months, maybe January. Yeah. Yep. Yeah. That's it. So that you can see there's a legend or key on the side. It shows we are looking at temperature. So working with, we partnered with NIWA to develop these maps, NIWA and SPREP through the VanKIRAP project. So we use the historical data from VMGD and also some satellite data to map out these rainfall maps. Yes, you have temperature and so two parameters, temperature and rainfall. So what we're looking at now is the temperature. So each island has their own map, and this is very useful because we are able to provide for each province just the islands. For example, the islands, you can click on Torba. Yes, you can. That's right, Pearl. Torba, yeah.
It's updating.
Yes, it's updating. So it will show you only the Torba Islands in a lot more detail and zoomed in. And you can select a month, and you can even select ENSO phase, whether it's going to be El Nino season or La Nina or neutral. And you can see the temperature variation for these islands. I think you can also click Pearl on seasons if you could try that.
Yeah.
Go to select period. Select
Okay.
period. Yeah.
Which one do you want? Dry?
Wet season.
Wet.
Yeah. Wet,
Okay.
yes. So you have these options. So now communities, just recently during World Meteorological Day, we were able to visit the Panama province, hand them the map and show them during wet season. You can look at this map. And if it's a wet season during an El Nino, you can click on the map and already see what kind of rainfall you will be expecting. So this is useful like across all the sectors, even those that are not partnering. Yes, as we know, weather, climate affects everybody, regardless. So yes. Thank you. Yes, you can click on the next link. Well, yes. Okay. So this is another information product that we give out. This is a long-term information that goes out to all the sectors, different sectors, NGOs, and this is more a long-term outlook of, yes, you can go down there. More, it's like the updated forecast. It's a prediction outlook. Yes, I said that outlook. So you can see that it's provided in the table. You can see the province and whether the dry or El Nino is serious for your area. You can see the stations on the site. And then that's also provided in the map. So there's the map. You can stop there for a second. Thank you, Pearl. So yes, the challenge there is well, the advantage is now you can see if you don't want to read tables, it's easier to look at the map. Preferably, people like to look at maps. They can see the island easily and see what the status of dryness or wetness for the island. The challenge with this still is the resolution, but it's going to get there eventually. Thank you, Pearl. I think we can go to the next slide. Do let me know if we are going over time.
We
So
are good.
this is another.
I'm checking, but we're doing good. Yeah, you're almost there anyway, right?
All right. So also with the project, this is just an extract from the portal itself, but yes, you can click on it, but I have an exempt there, so we can just look at this. This is for water. In the Climate Futures portal in partnership with CSIRO, we developed a climate change projection. What we are looking at on the PowerPoint is the water. It's a water case study based on Sarakata River. Sorry, yes, but this is, I'm talking to what you just saw before. But on the link there, you can see that's the sea level rise. So it's
this one
due to the availability of LiDAR data, which is only for certain areas, like it covered only Port Vila and Luganville. So the FAT in Port Vila covered up to this very big village, Mele village. There you can see the impact of sea level rise with projection. you can click on the emission scenarios. I think this is low emissions up to 20 something.
2019.
2055. 20, yes.
This one is 2019.
Okay, yes. So 100 years projection. You can see what the sea level might look like in 2090 with a lot of in government tourism investment along that coast will be underwater. And this is not to scare people, but it's to have people prepared and have options for investment solutions for the future. So that's on the sea level. Yes, yes, yes. Thank you. And then when you go to the water, then you can see that the catchment there's a lot. The catchment will just overflow. A lot of areas, villages living along the coastline, they will have to move in 50 years' time. Climate Futures portal is the link is there. Pearl, you can share it with everybody. I can share the passcode so that you can see what's available there if it's relevant for your query. Yes, next slide. Yes, so that brings me to the last slide. So best practices that we learned during the project. Using climate data to produce climatology atlas or historical maps is very, very useful. And we would like to continue to do that, but especially if that would be the resolution of the forecast, the models that we receive in the future. Number two, I mentioned that when we have increased spatial coverage of climate data, it also improves model output for small islands like Vanuatu and any Pacific islands, all small islands. It improves prediction. It provides precise information as well. And then the last one here is Vanuatu has been able to accumulate 30 years of historical data, and this was an advantage. We are continuing to build that. Apart from having automatic weather stations, we have people, but we also have what we call citizen science. So anyone within the community, we include schools. We involve them to collect rainfall data, but we also train them to become more like weather watchers, and then they report back to the headquarters here what they are seeing. And so we are able to see what we are forecasting versus what they are seeing on ground, the impact as well of drought, of rainfall, even volcanoes and earthquakes. But sometimes we get acid rain as well. So it only started, I think now it's up to 10 years. There's about 80 people. They are employed by the government. Now just within no qualification, no certificate, just basic climate 101 knowledge that we train them with. And in 30 years' time, we will be able to update our climatology maps with the data from our rainfall community network. And that brings me to end. Thank you, Thomas.
Thank you, Moirah. Thank you very much. Just to make sure everybody's still with us, I actually had if you had a few questions for Nicolas and Moirah already. you can. I'm gonna get your microphones and cameras on if you wanna ask a few questions already. Where is it? Ah. So easy.
It looks like we have one question from Jean, who's raising his hand.
Yeah,
So
sure.
Jean, please.
Thanks, Nick. Yeah, thank you very much for this presentation. Thank you, Thomas. That was really interesting. Actually, for both the presentations, but just reacting on the one from Vanuatu side. I really love the way you're working with the community. The local community is talking about citizen science, train them and so on. This is exactly what we aim to do at the regional scale when possible, according to the topics we want to prioritize altogether. My question was about so you've been talking about 80 people employed by the government, right? Just before, also talking about training schools and so on. So is this like a maximum of 80 people working, actually paid by the government that has been trained, but trained by yourself to get in situ data? Is this like any more people working without being paid, without being employed, such as schools and so on? Or are they all included in the 80 people?
Thank you, Jean, for the question. The 80 people does not include. We've also we also have rain gauges in schools, and there continues to be requests for rainfall gauges to be installed in schools. So the schools, they are volunteers. It's part of the education. So they are not contracted by the government.
Awesome, thank you. Sorry about that, my kid was behind. And so maybe the last question is like, would you be keen to work in a wider area instead of just Vanuatu? I mean, what you do within your own country could be, I guess, be done wider in a wider way, I guess. Yeah.
Of course. We would we would love to partner. We would love to work in a wider community, because sharing experience in a wider community motivates, especially people who are in the village, recording data like once a day. And when they know there's more people in a wider space, it really, really boosts their morale, and they know that they're part of something bigger. We recently had the whole of 80 people. We bring them out like on an annual forum to, continue to refresh their knowledge. So, and that makes it really boosts their work morale and capacity. Yeah.
Okay, so I'm not technical enough to ensure like the quality of the data, etc. If we do it, for example, at a regional scale, but just to highlight the fact that our Oceania, like community of Oceania Geospatial Dynamic, is pretty much to support such initiatives from you, like you do in Vanuatu. And if things like that could be done at a wider scale, at a regional scale, we would be the first one to support it. Also considering the fact that we do highly support in everything related to, taking into account the local communities. Most of the time they have the real capacity of getting in situ data. So this is the best powerful way to collect data. So really, really love this way. Thanks for that.
Thank you, Jean.
Yeah, I think this is something that we will talk about in another webinar, about how to get the local community to interact for GIS data and environmental data. So your experience here is going to be really good to share again on that particular focus, I'm sure.
Thank you, Pearl.
Yeah, Is there any other question for Nicolas or for Moirah? No. I guess we are. You know what? I wanted to do something. I wanted to take the picture of everybody that is connected now. So if you could please just turn on your camera, just to get a picture of all of us, and then I'm gonna give the floor to Rua. Oh, somebody's in the car with the kids. Great. This is great. Thank you, everybody. Okay, I'm gonna take the picture. Don't move. You can all smile if you want. 1, 2, 3. That's it. Up. I'm just gonna paste it. Up. That worked. All good. Thank you, everybody. And up. I'm gonna share my screen again to get Rua to talk. All right. Bulavina Kishan. Yes. All right. Share the screen here, and this is it. Up. Where is it? It's in here, I believe. No, that's not the one. Sorry. Tack. It's here. Rua, up to you.
Thank you, Pearl and Nicholas and Moira. Good morning, everyone. Today I'm excited to delve into the world of GIS rainfall data and explore the 3 key sources where you can download this vital information. So we'll be taking a closer look at the CHRS data portal, Global Climate Monitor, and the Climate Research Unit. So let's dive in next. So I'll just give a brief introduction about myself. I've already done, but so currently I'm working with the International Labour Organization in this development cooperation project called the STRAIght program. So I work as a GI specialist. So I work to develop the maps for the value chains of cocoa, vanilla, and fish, and also for the transport infrastructure in the project area. So most of the road data is unavailable. So I literally have to use a GPS or even satellite imagery to digitize these roads and have that information. So yeah, so prior to that, I was a GIS officer with PNG Forest Products, which is a logging company. Yeah. Next. So rainfall data is fundamental for a multitude of applications, ranging from agriculture and urban planning to disaster management and climate research. Accurate and reliable rainfall data is crucial for understanding precipitation patterns and making informed decisions. Today, we'll be exploring where you can access and download GIS rainfall data from 3 reputable sources. Next. So let's start with the CHRS data portal, the Center for Hydrometeorology and Remote Sensing, or CHRS. CHRS offers a comprehensive platform for accessing rainfall data. So here's how you can download data from CHRS. First, you visit the website, the portal on the link that's showing on the screen. So if you're new to the platform, you may need to register for an account. So once logged in, you can navigate to the rainfall data section. Then you can specify the location, the time period, and the resolution of the data you need. After selecting your preferences, you can simply download the data in GIS-compatible formats such as NetCDF or even a GeoTIFF, which is a raster. Next. So you can see in this example, since I'm from Papua New Guinea, I'm going to zoom into PNG and then select. You can select by clicking on already created polygons there and then select the file format, the time period, and then you can download the rainfall data for your analysis or other processing. Now, it will also ask you for an email address. So you enter your email address and then the download icon will become active. So you can just click and then it's downloaded as a zip file. Yeah. Next. So let's turn our attention to the Global Climate Monitor. So this platform provides access to a wide range of climate datasets, including rainfall data. So here's how you can download rainfall data from the Global Climate Monitor. So start by visiting the website, www.globalclimatemonitor.org, and then explore the available datasets and variables to find the rainfall data for your desired region and time frame. So once you've selected relevant data, you can choose the format for downloading, such as CSV, NetCDF. So after downloading the data, you can easily integrate it into GIS software for other analyses. Next. So here again is the example from the Global Climate Monitor. Various datasets that you can choose from. Time period needs to be selected. If you want for every year, you'll have to select yearly and then download that information in the desired file formats. You can select by country to filter and then download country data specific to your country. These are very good source of rainfall data that you can use. You can download as vector or even raster and use that in your analysis. Next. So our final stop is the Climate Research Unit or CRU, which offers valuable rainfall data sets for research purposes. So here's how you can access and download rainfall data from CRU. First, you access the CRU website from the link that's displaying on the screen right now. You navigate to the data section and select rainfall data sets that meet your requirements. You can choose the spatial and temporal resolution that best suits your needs. And once you've made your selection, download the data in your preferred formats such as ASCII, NetCDF. Remember to cite the data appropriately if you use research or publication purposes. Next. So in the next slide, we have again the example of how to do that. So these are different data variables, and I've selected the precipitation, the rainfall information, and the years, the time period is given with multiple file formats, so you can select which one you would like for your research or analysis purposes, and then click, and then it downloads. Next. So in this comparison table, we can see the key features of each data source, along with the respective pros and cons. The CHRS data portal offers a wide range of data options with high resolution, but it requires registration. On the other hand, the Global Climate Monitor provides a user-friendly interface with multiple data formats, although it has limited temporal resolutions. Meanwhile, the Climate Research Unit offers long-term consistent data quality, but some datasets may require payment and have limited spatial resolution. So consider these factors when choosing the right source for your specific needs. Next. So there's a research paper that I published called Ecological Zoning for Sustainable Development, a case study of the Momase region, East and West Sepik provinces of Papua New Guinea. It's on the International Journal for Innovative Science and Research Technology. So in this research, I used rainfall data, because rainfall data plays a crucial role in understanding environmental dynamics and guiding sustainable development initiatives. So the Momasa region study involved comprehensive mapping efforts to understand the ecological zones within East and West Pacific provinces. That's two projects that are involved with the STRAIght program that I'm currently working with. So by amalgamating rainfall, altitude, vegetation, and landform data, I identified distinct ecological zones that contribute uniquely to the region's environmental tapestry. So this synthesis of data provides valuable insight into the diverse ecosystems of the Momasa region. The synthesis of rainfall, altitude, vegetation, and landforms data resulted in the creation of the ecological zone map of East and West Pacific provinces. This comprehensive map provides a nuanced understanding of the region's environmental dynamics, highlighting the diverse ecological zones that exist within the area. So in summary, the study underscores the intricate interplay of ecological zones in the Momasa region in Papua New Guinea. So the ecological zone map provides a valuable resource for informed decision making, conservation efforts, and sustainable development initiatives. By integrating scientific insights with practical applications, we can work towards building a resilient and inclusive future for the communities in the region. So this is basically just an example of how rainfall data can be integrated into various other research and applications. Next. So as we wrap up our presentation, it's essential to reflect on the profound significance of GIS rainfall data and its applications across various fields, from agriculture and urban planning to disaster management and climate research. Accurate rainfall data serves as a cornerstone for informed decision making and sustainable development. Throughout our exploration today, we've covered three key sources: the CHRS data portal, the Global Climate Monitor, and the Climate Research Unit. And we learned how to access and download valuable rainfall data from each platform. So by understanding the unique features and capabilities of these sources, we empower ourselves, yeah, to harness the power of GIS rainfall data for diverse research endeavors and decision-making processes. So let me encourage each of you to further explore these resources, dive deeper into the available data sets, read the metadata, and leverage GIS rainfall data to address pressing challenges and drive positive change in your respective fields. Whether you're a researcher, um, a planner, a policymaker, integrating reliable rainfall data into your work can really enhance the accuracy and the effectiveness of your analysis and decisions. So in closing, I extend my gratitude to each of you for your attentive participation. Remember, the journey doesn't end here. It's just the beginning of a deep exploration into the vast world of GIS rainfall data. So together, let's continue to unlock its potential and make meaningful contributions to our communities and the world at large. And thank you for your attention.
Thank you very much, Moirah. It was very inspiring, and I love your conclusion, really. Does anybody have any questions for Moirah? The microphone is still open normally. No, it was so clear that nobody has any questions.
Oh, great.
Actually, you know what? I had some questions. So I had some questions for all of you. I made some other polls, and I'm going to launch them right now. The first question was, do you actually use a rainfall data yourself, like GIS rainfall data? But the first one I'm going to ask is, have you ever downloaded GIS rainfall data yourself, like what Moirah has been encouraging us to do, did you actually do it? I don't know if you can see the poll. I can. There we are. So for now, out of five answers, it's half and half. Almost. So we have seven answers, and more people actually answered no, but they never really download GIS rainfall data themselves. But now that we know we can find it, it's going to change. All right, great. 9 answers. I think we have everybody. If not, it's going to be, oops, I'm going to stop it right here. Thank you for this first answer. And then the second question is actually, if you downloaded it or if you didn't, but if you were actually using the GIS rainfall data, what would it be for? We know that RUA showed us to create the ecological zones. It could be for agriculture, it could be for urban planning, could be for pretty much everything. Could you just tell us what would you be using it for on your side, please? So we have drought forecast, agriculture, erosion, water security, research, flow forecasting, river forecasting, climate information, planning. We have planning coming back. Erosion, yeah, water is here. Good. You can actually answer as many times if you want, if you are using it for many different subjects. Great. Up. All right, flood and erosion are coming ahead. Great. Well, thank you for your answers. Is that it? I think this is it. We have 13 answers. And if I click on show the results, you should have the results. I'm closing the poll. Thank you all for your participation in this 2 polls. It's really great to see that we all have different usages of this data, and I like it. It's really great. Is there any more questions for RUA after this small interaction, or still no answer? Still no questions? I didn't look at the conversation. No. No. Well, I guess it was so clear from Papua New Guinea, but it's all good. Nicolas, is there anything else on your side that you would like to say?
No, just a big thank you to everyone who came to the webinar, and also to our speakers from Vanuatu and PNG, Moirah and Roa. Really great presentations, and thank you for sharing, and thank you to Pearl for facilitating and animating.
Yeah, thank you, Nicolas. So just to wrap up the webinar, I'm just gonna share my screen for the last slide. I just wanted to, well, I wanted to thank you all, yes, for being with us today. And I just wanted to let you know that our next webinar is planned on May the 13th, no, the 30th, sorry, still at 9 a.m. for Fiji time. And we're going to talk about climate change and water. And we are looking for the speakers as we speak. So it's going to be climate change and water, and the full topic is going to be announced. In the meantime, you can, what's the word in English? You can join us, sorry, on the LinkedIn group. So I'm going to put the LinkedIn group URL again in the chat. And yeah, you can already register for the next webinar. And as Nicolas said, I really want to thank you all for being with us today, because it was really great, and I really enjoyed the Vanuatu and the PNG and the Fiji presentation. It's really great. Jean, is there anything else you want to say?
No, actually said everything. Ollie, thanks for that. Everything is about sharing knowledge and experience and enhancing collaboration processes within the region. So glad to get you all, and hopefully new opportunities will come up from that.
Yeah. Well, thank you, everybody, and you all have a good day.
Thank you.
Thank you, everyone. Bye for now.
Bye.
Thank you. Thank you.
Thank you. Bye-bye.
Bye-bye.